Experiment 5 is about reaction rates and equilibrium. Part 1, rates of reactions, and Part A, nature of the reactants. So we are going to test the reactivity of zinc and copper in 6 molar hydrochloric acid. I already have the experiment set up, so I have zinc, and then I will have copper, and then this is zinc. So I'm going to put a strip of zinc in this tube, and then there's also the copper, and then I will put one strip in the copper tube, and then I also have the 6 molar hydrochloric acid, and I will put 5 ml in each tube. So one strip of zinc, and then also one strip of copper, so I put zinc at the bottom, and then copper strip, and then this is the 6 molar hydrochloric acid. So I'm gonna time it. So I will have the timer on, and then once I put the 6 molar hydrochloric, once I put the 6 molar hydrochloric acid, I will start timing. So you see bubbles at the bottom. So this is a reaction of zinc and hydrochloric acid, and it is evolving hydrogen, H2 gas. So it shows the reaction of the zinc with the hydrochloric acid. You see a lot of bubbles of H2 coming up. And then I'm going to put the same amount of hydrochloric acid, the same 5 ml. In the copper. Nothing is happening. So 1 minute and 30 seconds, it's continuously evolving H2 gas on the zinc and hydrochloric acid. So there was an instant reaction of the zinc and hydrochloric acid. However, for the copper, it's not moving. So after 4 minutes and 15 seconds, it stopped bubbling, so it completely reacted. So we don't see the zinc anymore. And however, for the copper, it's still unreactive. So in the lab report, you are now going to write the observations for the zinc and 6 molar hydrochloric acid, and then copper and 6 molar hydrochloric acid. So you are going to write the balance equation only for the reaction that occurred, which is going to be, in this case, zinc and HCl, and then write the products. So we're done with part A, which is nature of the reactants, and now we're going to do the concentration of reactants. We are going to use magnesium this time. So I'm going to measure 10 mL of 1 molar hydrochloric acid in one tube, and then the other tube will contain a higher concentration, which is going to be 3 molar hydrochloric acid. And then we will observe and record the time for the magnesium to react completely. So this is the magnesium, and I'm going to take one strip. Then put it in one tube, and then almost equal in size the another strip. So again, I have a timer, and then this is 1 molar hydrochloric acid, lower concentration, and then the other one, 3 molar hydrochloric acid, higher concentration. So I already measured 10 mils in a graduated cylinder. So when I put it, I'm going to set the timer, and then we observe. So again, you're gonna see, so you're seeing some bubbles in here. So again, lower concentration, 1 molar. And then I'm going to do the same thing for the 3 molar. I already measured 3 molar hydrochloric acid in the cylinder. And then we're gonna set the timer once I start pouring. So you can hear that fizzing sound, and you can also see the gas coming out. So obviously this one is much faster. Actually the magnesium disappeared, while however this one is still reacting. So that one in like 23 or 24 seconds it's done, while this one already 1 minute it's still reacting. You can see the bubbles, and this one stopped bubbling. So that's the effect of concentration and the reactivity. So the higher the concentration of a hydrochloric acid, the faster is the reaction. So this one almost done, and then it's gonna stop bubbling. So the reaction was done in 1 minute and 45 seconds. So in the report form, in this table, you are going to write the observations and record the time that it took for the first one, lower concentration, to react, and then also the higher concentration for that to completely react. And then what conclusion did you reach from your observations, and then write the balanced equation for the reaction. So both reacted. So reactants are magnesium and hydrochloric acid, and then write the products for this reaction. So that's it for part B. Part C is the effect of temperature in the reaction rate. So I'm going to heat up a water bath to about 50 degrees C, and then I'm going to place 10 mils of the 0.1 molar hydrochloric acid in the tube, and then the other one is going to be at lower temperature. I'm going to set up ice water bath to about 10 degrees C, and then I'm going to put in the tube 10 mils again of 0.1 molar hydrochloric acid, and then we are going to add a small amount of sodium bicarbonate into each tube, although I actually weighed it as 200 milligrams, and then we're going to observe and compare the reactivity in each tube. Again, we're going to time it. I have the sodium bicarbonate, it's NaHCO3, and then I also have the hydrochloric acid, it's 0.1 molar hydrochloric acid. And then I also have the amount, a small amount of sodium bicarbonate in the weighing boat. And then I have in here the low temperature. And then I have this on the hot plate. So the temperature right now is about 61. And then I'm gonna put it here. And then the temperature again for this one, lower temperature, is about 7.6. And now I'm gonna put for this one, the first one, low temperature, and then I'm gonna set the timer. And then the higher one, so set the timer. So there's a lot of bubbles in the high temperature, while this one not a lot. You can still see, but it's slower. It's still reacting. However, this one is done. There's still a little bit at the bottom, but it's done. So it's about 20 seconds for the high temperature. However, this one is still reacting, and it's about 38 seconds. So completely reacted at about 1 minute and 15 seconds. So that's the effect of temperature on the reactivity or in the reaction rate of sodium bicarbonate and hydrochloric acid. In the report form, you are going to write temperature, and then observations, and then conclusion. And then you are going to write the balanced equation for the reaction. So it's NaHCO3 plus hydrochloric acid, and then you're going to write the products of the reaction. So again, write the balanced equation for the reaction, NaHCO3 plus HCl, and then what are the products, and then balance the equation. So that's it for part C. Part 2 is reversible reactions and equilibrium. We are going to do the effect of stress in an equilibrium reaction. So the equilibrium reaction is about copper hydroxide forming copper plus 2 and OH minus. So the reaction is shown in this table. And so we are going to add copper chloride and then sodium hydroxide. It will form copper hydroxide. The copper hydroxide solid will be in equilibrium with the copper 2 plus and then hydroxide ions. So if we add more hydroxide ions, it will form more of the solid. So that's the first part. That's tube 1. Test tube 2, if we are adding ammonium hydroxide, it's also a base, it's going to form also copper hydroxide because you're shifting the equilibrium to the left side. So again, the first one, you are adding sodium hydroxide. You are going to shift it to the left side. If you're adding ammonium hydroxide, it's going to shift also to the left side. So if you're adding hydrochloric acid in the equilibrium, it's going to react with the OH minus. Therefore, it's going to shift it more towards the right side. So I now have here the tubes. So I have here copper 2 chloride. So it's blue. And then I also have the sodium hydroxide, 0.1 molar. And then I also have ammonia or ammonium hydroxide in water. And then I also have hydrochloric acid. So on the first tube, I have just copper chloride, the first tube, tube 1, 2, 3. It's all copper chloride, 3 mL. I'm now going to add equal amount of sodium hydroxide in the first tube. So let it react. So you can see formation of precipitate. So there's a solid at the bottom. Okay. So on the second tube, I'm going to add equal amount. So I'm going to add equal amount of the sodium hydroxide. And then the same thing, I'm going to add equal amount on the other tube. So I'm just pouring it. So I added sodium hydroxide in all the tubes. So you can see that you can see the precipitation. So we let it react, and then we want to see some precipitation like this. So I just added this and it's already forming. Okay, so you see some solid at the bottom. So we're gonna see how it would behave if you add more of the base. And then what happens if we add ammonium hydroxide, and what happens if we add hydrochloric acid. So I'm gonna add additional sodium hydroxide, about this much, and then see how it works. So you can see that compared to this one, you have more precipitation. And now I'm gonna add now ammonia or ammonium hydroxide in this tube. So approximately the same quantity as the first one. So that's ammonium hydroxide. It has different effect, but actually produced also more precipitation. But the color actually became more blue, as opposed to an aquamarine-like blue color. And now we're gonna add hydrochloric acid in this tube, and almost the same amount. So let it settle. So you can see that there's less precipitation on the hydrochloric acid. You have more precipitation on the sodium hydroxide as well as the ammonium hydroxide. Adding a base, you have more formation of the solid. However, adding an acid, you have less formation of the solid. Actually dissolves to form more the ions on the right side of the equation. So this one has less precipitation, this one has more at the bottom, and then as well as this one. So you can see the bottom actually has more at the bottom, the same thing as that one, but less in here. So adding a base will make it precipitate more, while adding an acid will make it precipitate less. So that's the effect of adding certain reactants in the equilibrium of the reaction for a reversible reaction. In the final lab report, you are going to write the effect of adding more sodium hydroxide and in which direction did the equilibrium shift. Next page, test tube 2. What is the effect of adding ammonium hydroxide and in which direction did the equilibrium shift? And then test tube 3. What is the effect of adding hydrochloric acid, and write the balanced equation for the reaction when HCl is added. That's it for this experiment.